So, they're all. This is the second, first topic of the part. That is regression modeling. Yes, we introduce this subject. Explore this word data analysis. So data analysis and what really the data analysis is on with the help of the machine learning. How machine learning help us in data analysis. Now we need to understand what really the regression analysis is. Regression modeling is. See, first of all, we will understand, then we will go for it. We do some prep learning out here, some internet resources as well. So regression is a method to particularly formulate a relationship between variables. So we need a variable set that is due to course can be used to estimate, interpolate, or extrapolate. If there is interpolate and extrapolate, we need to design a some graph. Okay. Suppose you want to estimate the weight of individual, which is influenced by height, diet, workout, etc. Weight is a predicted variable. Height, diet, workout, predictor variables. So we need to make a relationship between different variables. Here, the variables for the input is predictor is height, diet, and workout, and the predicted is weight. So the predicted variable, this one, height. Predictor variable is dependent variable in the sense that it depends on the predictors. So predictor variables are called independent variables. This predictor height, diet, and workout here is independent variables. And regression reveals extent the predicted variable is affected by the predictors. And with the help of the regression modeling, we will be able to understand which this different variables of the predictor will help to the predicted. So regression reveals what extent the predicted variable is affected by the predictors. In other words, amount of the variation in the predictor will result in the variation in the predicted variable. Okay, predicted variable is mathematically represented as y, and the predictor variable is mathematically represented as x1, x2, x3. Y is our weight, and x1, x2 is height, diet, and workout. This will create a mathematical relationship often called a regression model. Okay, so regression analysis is a statistical method to model the relationship between a dependent, that is target, and independent variables with one or more independent variables. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. It predicts continuous by a real value such as temperature, age, salary, price, etc. Regression is a branch of the statistics. First of all, we need to understand. In the previous lecture, we understand how statistics help us to understand the data, which is data house with the towards big data for the collection network, for making a big network of a data network of the data warehouse. You can say that. So this branch of the statistics help us to get a predictions, and we understand it will help us for prediction. Now this prediction will be done with these models like regression model. What really is, it is a branch of the statistics which is implemented with as an algorithm method. So when the algorithm is implemented with the data, then machine learning happens actually. So there are different types of regressions. So what are the different types of regressions are? We have linear regression, we have polynomial regression, we have support vector regression, we have decision tree regression, we have random forest regression, we have ridge regression, we have lasso regression, we have logistic regression. So there are different type of regressions out there, because always the thing is that the independent and dependent variable will be changed according to the business needs, and predicted variable and predictor variable will also change. That's why we need a different type of regressions actually. So first of all, we need to understand what really the regression is all about. Now, we should understand what before moving towards next. So first of all, really understand what really the regression means. Regression means a return to a former or less developed state. Actually, the regression means a return to a former or less developed state. Why we are saying in statistics a measure of relations between the mean value of one variable, that is output, and the corresponding values of other variables like time and cost and etc. So in the term of the statistics, regression is a statistics method used in finances, investment, and other discipline that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by y, and a series of other variables known as a independent variable. So, what really regression will do? Really, regression will regress to me. The word this regression will give us a regress to me. Okay. We try to get a thing like in a corona, we can say that we will, with the help of the regression modeling, we can get a trend or shift towards lower or less perfect state, such as a progressive decline or a manifestation of disease. You know, gradual loss of differentiation and function by a body part, especially as a psychological change in movement means. There are many things we can do with the help of the regression. So, regression analysis is a set of statistical method used for estimation of the relationship between a dependent variable and one or more independent variable. It can be utilized to assess the strength of the relationship between variables and for modeling the future relationship between them. So, in terms of the statistics, we understand what really the regression is all about. Let's go in terms of the machine learning. Regression is a supervised learning technique which helps in finding the correlation between variables and enable us to predict the continuous output variable based on the one or more predictor variables. You know, we have a different predictor variables, and we will we'll predict a continuous output variable with the help of the predictor variables. Like we use this in the forecasting methods. We with the help of different variables we can predict the output. So yeah, so the regression is mainly used for the prediction, forecasting, time series modeling, and determining the causal effect between variables. Okay. So what really we do the regression or a regression modeling? In regression, in general, we plot a graph between variables which best fits the given data points. That data points will be predictors, and we will predict some continuous output. And the machine learning model, can make predictions about the data. In simple word, regression shows a line or curve that passes through all the data points on a target predictor graph in such a way that the vertical distance between the data points and the regression line is minimum. Distance between the data points and the line tells whether a model has captured a strong relationship or okay. Next move is where the actually we work with regression. We work with the regression as a prediction of the rain using temperature and the factors. We predict the yes storms, determining of the market trends, prediction of the road accidents due to rain. Okay. Okay. Next is what are the terminologies related with the regression? like we have dependent variables. Always dependent variable keep us down. Dependent variables are like dependent variables is like the main factor in regression analysis, which we want to predict or understand is called the dependent variables. It is also called target. Okay. Next is independent variable, the factor which affect the dependent variables or which are used to predict the values of the dependent variables are called independent variables. Are also called predictors. What are outliers? See, outlier is an observation which contains either very low value or very high value in comparison to other observed value. Okay. Outlier may hamper the results, so it should be avoided. Next is multicollinearity. Multicollinearity. So the independent variables are highly correlated with each other. Other variables, then such condition is called multicollinearity. It should not be present in the data set because it creates problems while ranking the most affecting variable. You know, that zeros part, where the multicollinearity happens. Next is underfitting and overfitting. If our algorithm works well with the training data set, but not well with the test data set, then such problem is called overfitting. We are fine with training data set, but not working well with the problem. And if our algorithm does not perform well with the training data set, then such problem is known as underfitting. We need to understand what really these technologies are, which will help to make the model different needs. We have the footprint tag. Next. Next is why do we do regression analysis? As you mentioned above, regression analysis help in the prediction of a continuous variable. There are various scenarios in the real world where we need some future predictions, such as weather conditions, sales prediction, marketing trends, etc. For such case, we need some technology which can make prediction more accurately. So for such case, we need a regression analysis, which is a statistical method. Okay. And used in machine learning and data science. Below are some of the reasons for being regression analysis. First is regression estimates the relationship between the target and independent variable. Second, it used to find the trends in data. It helps to predict real by continuous variable values. By performing the regression, we can confidently determine the most important factor, the least important factor, how each factor is affecting the other factor. So regression in general, regression analysis is divided into three types. That is linear regression, which we call a linear, multiple linear regressions, and non-linear regressions. So for really understanding of this, okay, let's understand this three. Then we'll move for the seven types. Okay. So we understand that there are variations of the regression analysis, which include several variations such as a linear, multiple linear, non-linear. Most common models are simple linear and multiple linear. Non-linear regression analysis is commonly used for more complicated data sets, in which dependent and independent variables shows a non-linear relationship. Okay. The regression analysis offers numerous applications in various disciplines. Finances. So let's understand different model structures. So dependent and independent variables show a linear relationship between a slope and intercept. We will understand when we see the graph of the linear relationship. The independent variable is not random. Okay. Third, the value of the residual error is zero. The value of residual error is constant and across all observations. Next is the value of residual error is not correlated across all observations. The residual error values follow the normal distribution. Okay, these are some constraints we need to follow when we say this is a regression analysis. Now, what is the linear regression analysis is all about? So, this is a very simple regression, linear regression analysis. Here, we simply find out a relationship between dependent variable and independent variable, and we just put it in a line equation that is y is equal to bx plus residual errors. So where y is a dependent variable, x is a independent variable, and a is intercept and b is a slope. And second type of is like logistic regressions. Logistic regression is one type of regression analysis technique which gets used when dependent variable is discrete. When the dependent variable, when the output is either 0 or 1, we're trying to get the things. Okay. So logistic regression is one of the types of regression analysis technique which we get a dependent variable in discrete form. Example 0 or 1, 2 or false. This means the target variable can have only two values. Its output can be only two. And the segment curve denotes the relationship between the target. This is the segment curve. Relationship between the target variable and the independent variable. Next is logit function that is used for the logistic regression to measure the relationship between the target variable and independent variable. Below is the equation that denotes the logistic regression. Logit log b divided by 1 minus b naught plus b1 x1 b2 x2 bg x2 dot bx, where b is the probability occurrence of the features. With this graph, which is known as segment curve, we are able to get whether it will happen or not. We will define the test set in the 0 or 1. For selecting the logistic regression, the regression analysis technique, it should be noted the large set of equal occurrence of values to common target variables. And there should be no multipolarity, which means there should be no correlation between the independent variables in the data set. Okay. Next step is it's a regression analysis. Multiple linear regression. What is the multiple linear regression? Many lines actually. So multiple linear regression analysis is essentially similar to the simple linear model, with the exception that multiple independent variables are used in the data model. The mathematical representation of the multiple linear regression is y is equal to a bx1 plus cx2 plus dxt plus residue. Y is dependent variable, x1, x2, s is independent variables, A is interceptor, PCD is slope, E is a residual error. Multiple linear regression follows the same condition as the simple linear model. However, since there are several independent variables in multiple linear analysis, there is another mandatory condition in the model, that is not collinearity. Independent variables should show a minimum correlation between each other. If the independent variables are highly correlated with each other, it will be difficult to access the true relationship between dependent and independent variables. So we need to go for some discrete, prudent choice of the input variables. Okay. For understanding machine learning algorithm through regression, we have many type of the regression thing we have, as we know. Okay. So, like we have this decision tree regression as well. It is basically used in machine learning algorithms. So regression is a very vast field. We are getting a different type of regression, but we define two, mainly three. This is simple regressions, logistic regressions, then multiple linear regression. Okay, three regression we defined, but we understand that there are these seven types. Linear regression, between the linear and logistic regression, we have polynomial, support vector, decision tree, random forest, range regression, lasso regression. Here we are defining the decision tree regression. What really the decision tree regression is all about? So decision tree can be used for both regression and classification. Here we focus on the use of decision tree to predict the numeric value. Decision tree split the data set into subset and a specific node using a standard deviation reduction. So we create a data set where then it is divided into different subsets and a specific node using standard deviation reductions. Sample of data points with similar values and homogeneous should have a very small standard deviation. Okay. Mean and standard deviation are then used to compute the coefficient of variations. See, this is the formula, like summation of x by n, hence x by 2 x minus formula for mean, formula for standard deviation, because we are with the help of the reaction we are actually comparing with the mean variables. That's what we have learned with the definition of the regression. So the formula of the mean is this: x bar is equal to summation of x by n. What is the formula of standard deviation? This is this s square root summation of the x minus x bar whole square divided by n. When we use decision tree for regression, we're concerned with findings that attribute that the return largest standard deviation reduction. We choose the attribute with the largest SDR as the splitting nodes. Iterative repeat at the process and some stop. Coefficient of variation is smaller than the threshold value. When the coefficient for a branch becomes smaller than the threshold of 8%, then we stop splitting the node because the branch is homogeneous enough. So we need to go for the homogeneous data without any relation. That's not a multipolarity. So where we use these decision trees, like whether the weather will be rainy, sunny, or overcast, temperature will be hot, mild, or cold, humidity will be high to normal, whatever. According to the condition. So what is the step to get for this decision tree regression? First of all, we compute the standard deviation of the target. Then we split it into different data, like weather, temperature, humidity. That will be input actually. Compute standard deviation each branch for the split. This result is subtracted from the standard deviation before the split for this deviation formula. Then we'll go the attribute with the largest standard deviation reduction due to splitting the nodes. In our case, whether it's choose another root node. Then we divide based on the value of the selected attributes until some stopping criteria. CV at a particular node is more than the threshold and the branch is not homogeneous enough, and we split further by choosing each of the largest SDR. If the CV's particular node is less than the threshold, it becomes a leaf node or the branch homogeneous node. There are many other techniques you can use the regression problems, such as neural network and polynomial regressions. Okay. And we have understand what really the binary classification is all about. That is a logistic where we go for the true samples or false samples and create a boundary. For this, we need to go for this log function log. Px and the vector components dx is equal to b naught plus b naught x. This and where b naught plus b naught x is just the intermediate input is, and we always create some segment graph and we try to get a result true or form false. Where here we calculate the standard deviation with the formula 1 by 1 plus e to power z. Okay, so the null there, and then we go for some performance deviance when we implement logistic regression. So when we implement logistic regression, so null deviance is the response is predicted by the model with the intercept term, and the response is predicted by model with the intercept term and additional predictors. Residual deviance is much smaller than the null deviance. We can conclude that including additional parameters significantly improve the model accuracy. Actually, this is the introduction of the regression analysis. We have only also some theoretical part. We can best learn when it is implemented. Let's go some slide to understand it. Actually, so in this article, we are focusing towards the 7 types of the linear regression, okay, which is used in the machine learning, and we understand what really the machine learning is all about. In the machine learning, we get this graph, regression analysis. For the we try to create a significant relationships and the impact of the dependent variable on the of multiple independent of here we basically understand the relationship between the dependent variable and independent variable and extent or impact of the multiple independent variables on a dependent variables. So we have for the regression we always depend upon the number of variables, shape of the regression line, what we have discussed, that's seven type of the dependent variables. What we do in this linear regression we get a line like this, where here we that height and weight what, and we create this line, and and this where this formula best fit in. And then this is the how to obtain this deviation. We obtain it by fitting that standard deviation process, which is known as the R square metric. Important thing is that the input data should be free from the multipolarity, autocorrelation, heteroscedasticity. Linear regression should have a minimum outliers. Should be follow the forward selection, backward elimination. Okay, so for this we have some codes actually. Next is here it is logistic regression. Logistic regression we understand is it is the value of the 0 or 1. So with this example, we came across that it is a segment graph, and here we are putting all set in 1, data in 0. So there is we will classification, and it help us in classification problem and putting it in the 0, 1 and a 2. It's a polynomial regression or multi-linear regression. This is a polynomial regression. We change the input with time and we get a linear curve, which is known as a polynomial regression. Okay. Power of the independent variable is more than 1. Yeah. And formula is a plus b cross x to the power. And from this we are getting this relationship. What we have defined that underfitting, overfitting, and just right. So in the underfitting, we understand whenever we are applying and training data set, we are not getting our result. In the overfitting, when it is used for the model, then when it is used for the training data set, it was best suited. But when used for the model, is not suited. But this graph is just trying to get our information. We have also stepwise regressions. Okay, we usually put this in higher dimensionality data. We have ridge regressions. Ridge regression is technique, basically when the data suffer from multipolarity. So we try to go for this. There are many ways to get the regression. These are not so much important to our university perspective. That's why I'm giving an introduction. Then we have a lasso regression. That is the least absolute shrinkage and selection operator, which we reduce the variability and improving the accuracy of the regression models. We have elastic net regressions. This is also, you know, in Lasso, we put one of the random application, but in the elastic net we try to get more randomized things, so it can be linearized in the regression. So this is something, you know, we got in a regression model. When we understand it, then we implement as per the need of the business. I hope you got an introduction of the regression model, and so you are able to write up your answer and implement in the future as well. We will understand some practical application in our labs, but right now it's understanding.